Hello. Right. Another focus of 9.2 is what we call the rebound impacts. And a good way to illustrate that is to say that we have a wall and then we have a bouncy ball that was, fired at that wall with an initial velocity of u. By the way, let's use our coordinate system. If it's going right, it's plus. If it's going left, it's minus. If it's going up, it's plus. If it's going down, it's minus. So as the ball is approaching the wall with an initial velocity of plus u, when it hits the wall, it bounces back, okay? With the same velocity, we're going to assume that there is no loss of speed with the same velocity, but its final velocity will now be v, but with minus, because it's now moving in an opposite direction. You remember that velocity is a vector quantity. So if the ball, like this ball, okay, if it hits the wall and then it bounces back, then it hit the wall with a speed and it bounces back with the same speed, provided there is no loss of speed. We then say that we have a change in velocity. That will be delta v will be equal to, what's our final velocity? Minus v minus the initial velocity u. But because v equals u, because we say there is no loss of speed due to impact, okay, that's the assumption we make. We can then say that delta v equals minus u, which is equal to minus 2u. So that would be the change in velocity of the ball that is rebouncing after hitting a wall. So where do we go from there? We then look at the change in momentum. But in this case, we have to look at what we believe to be momentum before. Okay? Should be equal to momentum after. So momentum before is mass times u, and the momentum after will be mass times minus v. Right. So if we want to now look at the change in momentum delta p, it would then be minus mv, which is momentum after, minus mu. So if we factorize, m will come out. We now have minus v minus u, but since we say that this is equal to minus 2u, we now have minus 2mu. So in a rebound impact scenario, the change in momentum is mass, twice the initial momentum in a negative direction. So how do we proceed from there? We can then find the impact force. As usual, the impact force experienced by either of the, by the ball or the object would then be change in momentum over the time of impact, and in this case it will become minus 2 mu over t. So that is an expression for the force of impact on a rebounding or rebouncing ball on a wall or on an object. So let's stop here, because the second scenario we'll be looking at a case where the ball is actually hitting the ball at an angle, which is called an oblique impact, rather than hitting it at 90 degrees. If you look at this scenario, it's actually hitting the wall at 90 degrees. So the next scenario will be, what about if the ball is hitting the ball at an angle? And that will be looked at in our next video clip.